Okay. Good evening, everyone. So these are the things we are going to discuss today. In chemistry, we are going to discuss mole concept through questions. Okay. So first question I have taken is, let us consider 4 grams of sodium hydroxide. Find out the number of moles and find out the number of molecules of sodium hydroxide. Okay. So for that, first thing that is needed is molecular mass. And how do you find out molecular mass? Molecular mass, to find out, you need the atomic masses, right? So we need the atomic mass of sodium. Sodium atomic mass is 23 plus atomic mass of oxygen. Oxygen is 16 plus atomic mass of hydrogen. Hydrogen is 1. So we get 40. So the molecular mass of sodium hydroxide is 40. So how much is 1 mole of sodium hydroxide? 40 grams. Okay.
Yes,
now
sir.
Let's say we need to find out the number of moles. Number of moles is given by the given mass in grams divided by the molecular mass. This is very simple. In fact, if you see, it is basically, if you analyze, it is a very simple problem, like, one chocolate costs 10 rupees. How much 2 chocolates cost? 20 rupees. That's all, like that, right? 1 mole of sodium hydroxide is 40 grams. 2 moles will be 80 grams. Half a mole will be 20 grams, like that. Okay. But anyways, if you
Yes,
go
sir.
by formula, you don't have to think much. That is why I'm giving you the formula. But some of you can even visualize and answer it, right? For example, 40 grams of sodium hydroxide will be 1 mole. So 4 grams will be 0.1 mole. Directly you can get the answer. But I'm telling you, even for the PU purpose, you may have to do it by the formula. So that's why I'm telling you all this. Given mass in grams. What is the mass given here? 4 grams. So you substitute 4 here. Okay. What is the molecular mass? We found it 40. Therefore, the number of moles of sodium hydroxide is 1 by 10, which is 0.1. That's all. So the number of moles is 0.1. This is the first question I asked, right? The second part of the same question is, find the number of molecules, right? Okay. I will give you a formula for number of molecules also. So number of molecules is going to be nothing but the number of moles. Once you know the number of moles, finding the number of molecules is very simple, right? Multiply it with Avogadro number. That's all. Multiply the number of moles with Avogadro number. This also is the same calculation, right? If you see, 1 chocolate 10 rupees, 2 chocolates 20 rupees, same concept, right? 1 mole of sodium hydroxide or any compound will contain Avogadro number of molecules. 1 mole contains Avogadro number. 10 moles will contain 10 into Avogadro number. 2 moles will contain 2 into Avogadro number. 0.1 mole will contain 0.1 into Avogadro number. That's all. Immediately you can answer the question, but you can go by the formula, so that not much of thinking is required. So if you see, number of moles in this case is what? 0.1 into Avogadro number. What is Avogadro number? 6.023 into 10 to the power 23. That's all. That's going to be the Avogadro number, right? So if you see, this is nothing but 1 by 10. 1 by 10 multiplied by 10 power 23 will be 10 power 22. So the answer will be 0.6.023 into 10 to the power 22, right? So very simple. How do you find the number of moles? Given mass in grams divided by molecular mass, step 1. If you want to find out the number of molecules, it is very simple. It is number of moles into Avogadro number, all right? Let's take one more example so that this is very clear for everyone. Let's take one more example, okay? Okay, let's look at $250 grams of calcium carbonate. They may not give you the formula directly. They'll give you in words. You need to know the molecular formula. Once you know the molecular formula, next step is you will find out the molecular mass. Once you find out the molecular mass, you can find out the number of moles using number of moles is equal to given mass in grams divided by molecular mass. Correct? Okay. So let's do that now. So calcium carbonate. What is the formula for calcium carbonate?
CaCO3.
Yeah, CaCO3. Right. So now first let's find out the molecular mass of calcium carbonate, for which you need to know the atomic masses of each element, right? What is the atomic mass of calcium? 40. What is the atomic mass of carbon? 12.
12.
What is the atomic mass of oxygen? 16. And how many atoms are there? 3 atoms are there. Therefore, it must be 3 multiplied by 16. So you can see it is 40 plus 12, 52 plus 48. So answer will be 100. So the molecular mass of calcium carbonate is 100. All right. Once we know this, we can find out the number of moles very easily. So the number of moles will be equal to given mass, right? Given mass in gram. Because sometimes they may give the mass in kilogram, they may give it in megagram, whatever it is, right? You must be able to convert it into grams and then substitute here.
Sir.
Yes, Kagan, you have a doubt?
Yes, sir. What is megagram, sir?
Mega is 10 power 6. Milli,
Okay.
10 power minus 3. Micro, 10 power minus 6. Nano, 10 power minus 9. Like that we can have kilo. Kilo, what is it?
10 power 3.
10 power 3. Capital M. You can call it as mega or you can call it as million. It is 10 power 6. Then you have giga.
Yes, sir.
I think I've learned about gigahertz and all that, right?
Yes, sir.
Frequency, yes. So that is going to be 10 power 9 or a billion, right? Okay, all these things will be important for you guys. There are also other things like pico. Pico represents 10 power minus 12 and all that. But at this point, at least this much is good. Good, Kagan, to ask this question. Okay.
Yes, sir.
Given mass in grams divided by molecular mass. So what is given mass in grams? What is the mass of calcium carbonate which is given in the question? 250 grams. That you substitute here, divided by the molecular mass. What is the molecular mass of calcium carbonate? 100. Therefore, the number of moles
2.5, sir.
becomes equal to 2.5. All right. So that's the first part of the question, right? Number of moles. The second part of the question is, let us say, number of molecules. How many molecules are there in 250 grams of calcium carbonate? So first step is you find the number of moles. Then you can find the number of molecules. Number of molecules present in 250 grams of calcium carbonate. So I have told you the formula. How do you find the number of molecules? It is number of moles multiplied by the Avogadro number. So it's nothing but number of moles multiplied by Avogadro number, right? So here number of moles, how much we got? We have got 2.5. Therefore, it will be 2.5 multiplied by Avogadro number. What is Avogadro number? 6.023. into 10 to the power 23. Of course, you can use calculators as far as your competitive exams are concerned. Sorry, your board exam is concerned. But competitive exam, how you can do is you can do approximation. Don't do approximation in your board exam. Use your calculator. But in competitive exam, how I will recommend you to answer is approximate 6.023 as 6 itself. Because you'll be given options, right? So you can see whichever is the closest option, correct? 2.5 into 6. What is 2.5 into 6? That will be 15, correct? Because 25 into 6 is 150, correct? So 2.5 into 6 will be 15. So it's 15 into 10 to the power 23. Or I can say 1.5 into 10 to the power 24 molecules. All right. So this is another question. I hope so you are clear now with how if I give you a mass, if it is not given in grams, you should convert it into grams. Then find the molecular mass. Given mass divided by molecular mass will give you number of moles. Once you find number of moles, number of molecules can be found by multiplying number of moles with Avogadro number. All right. Okay. Okay. There are also further developments which we can do, which we will see in subsequent sessions, because I am just here to give you the basics today. Okay. Just an overview. Okay. The question can be detailed, right? I can ask how many atoms of calcium are there in 250 grams of calcium carbonate. So in that case, what I can do, very simple. It's not complicated, simple. One molecule of calcium carbonate has how many atoms? One atom. So now how many molecules are there in this? 1.5 into 10 power 24 molecules are there. Therefore, how many atoms of calcium will be there? Same number of atoms. 1.5 into 10 power 24 atoms will be there. How many atoms of carbon will be there? Same. 1.5 into 10 power 24 atoms of carbon will be there. But what about oxygen?
Divide by 3, sir.
No. One molecule contains 3 atoms, right? So 1.5 into 10 power 24 molecules will contain 1.5 into 10 to power 24 into 3. So it will be 4.5 into 10 power 24. Okay. Anyways, then I can go into how many electrons are there, how many protons are there. All these questions can be asked. But right now, I just wanted to limit my discussion to the basics. Okay. So that you are clear with this aspect. Okay. I hope it's clear to you. Okay. Now let's go to the next concept that we want to talk about is relating. We have now related number of moles to, weight, whatever I give, mass I give, that how you can convert into moles we have seen. Similarly, how many molecules are there, that how to find also we have seen, right? Reverse also you should be able to find out. Okay. We will take up a couple of questions. Let's take up a third question. So I will do the reverse, okay? What is the mass of what is the mass of 12 into 10 power 23 molecules? Sulfuric acid. Right? Earlier question, I gave you the mass. I asked you to find out the number of moles. Then from number of moles, I asked you to find out the number of molecules. Correct? We are going to now do the reverse process. So now we are given number of molecules. Now we will find out the number of moles. Then after that, we will find out what is the mass. Right? Okay, mass in grams. Fine. So let us see. So how many molecules are there? 12 into 10 power 23 molecules. Correct? Now the number of moles. So the number of moles is given by the number of molecules given divided by the Avogadro number. Right? If I have 6 into 10 power 23 molecules, or accurately, if I have to say 6.023 into 10 power 23 molecules, then how many moles are there? 1 mole. Because 1 mole of any compound contains Avogadro number of molecules. Is it clear? So I say 6.023 into 10 power 23 molecules are there of a particular compound, then I can be sure that there is 1 mole. Same calculation, right? So if 12.046, accurately if I have to say, 12.046 into 10 power 23 molecules are there, then how many moles are there? 2 moles. Approximately if I have 18 into 10 power 23, then I have 3 moles. Suppose if I have 24 into 10 power 23 molecules, then it is 4 moles. So how do I say it? Very simple. You can use this formula. If you're not able to think like that, you can use the formula and comfortably do it. So number of moles is given by the total number of molecules divided by the Avogadro number. All right. So now let's find out the number of moles in this question. So this does not depend on the molecular mass or anything, right? Whatever be the compound, it doesn't matter. So number of moles, what is the number of moles here? Number of molecules, what is the number of molecules given? 12 into 10 power 23, approximately. And approximately your Avogadro number is 6 into 10 power 23. Please avoid your approximations in your PU tests, but you can use it very well in your competitive exams. So you can clearly see that 10 power 23 cancels and 6 and 12 2 times. So the number of moles is 2. Is it clear? Okay. So the number of moles of sulfuric acid is 2. Okay. What is the next thing that we have to find? We have to find out the mass. Correct? Okay. I'll tell you how do you find the mass? So mass of a given compound this also, if you want, you can take it as a formula. But once you are very comfortable, you don't need a formula, okay? In fact, in competitive exams, once you're very thorough, then you can just do it mentally, right? If the same question is asked, once you're very thorough, how you will answer it? Okay, how many molecules are 12 into 10 power 23? That is 2 moles, because 6 into 10 power 23 is 1 mole. So 12 into 10 power 23 will be 2 moles, right? Done. Next, what is the mass of sulfuric acid? For that, you should know the molecular mass. Molecular mass of sulfuric acid, you would have done the sums many times. So you would remember it. It will be 98. So 98 is for 1 mole. 98 gram is 1 mole. How many moles are here? 2 moles are there. So 2 into 98. So that's 196 grams. So you'll finish the answer immediately. Okay. But right now, don't worry. You're just learning. So take your time. Okay. So mass of a given compound is given by number of moles multiplied by molecular mass. So mass of a given compound is in grams, okay? Mass of a given compound in grams will be equal to number of moles multiplied by molecular mass, all right? So in this case, what is the number of moles? It is clearly given as, we got it as 2 multiplied by molecular mass of sulfuric acid. So how do you find that? We have already done it in the class, but I'm just doing it for the benefit of everybody once again. First, you should know the molecular formula for sulfuric acid. What is the molecular formula for sulfuric acid? It is H2SO4. Now we need to find out the molecular mass. For knowing the molecular mass, or for finding out the molecular mass, you need to know the atomic masses. Am I right? So what is the atomic mass of hydrogen? 1. How many atoms are there? 2. Therefore, it is 1 into 2. Right? Plus, how many atoms of sulfur are there? 1. And what is the atomic mass of sulfur? 32. As I told you, you're expected to remember the atomic masses of the first 20 elements. All right. The atomic numbers, first 20. You should know the atomic masses also. All right. Oxygen. Oxygen, what is the atomic mass? 16. How many are there? 4 oxygens are there. So it is 4 into 16. So we have 2 plus 32 plus 64. It's 96 plus 2, 98. Therefore, the molecular mass of sulfuric acid is 98. So you'll have to substitute that here, 98. And as I told you, the answer will be in grams. Okay. So the answer is 16, 18. So 196 grams. So 12 into 10 power 23 molecules of sulfuric acid will weigh 196 grams. Clear? So you can go through it once more. I gave you mass of 12 into 10 power 23 molecules of sulfuric acid. First, we found the number of moles. Number of moles is given by number of molecules divided by Avogadro number. So that is 12 divided by 6, right? That will be 2. So number of moles is 2. Now, mass of a given compound is given by number of moles multiplied by molecular mass. What is number of moles here? 2 moles. And molecular mass of sulfuric acid is 98. Therefore, it will be 2 into 98. And the answer will be in grams. So it is 196 grams. That's the answer. I hope it's clear to you. Now we have seen number of moles, that is a mass given, convert into moles, then moles to number of molecules. Then reverse also we have seen number of molecules to number of moles, then number of moles to mass. Is that clear? All right. Now what we are going to see is atoms, right? Individual, let's say if you have an atom, then 1 mole of that atom, how many atoms does it contain? That element. We have seen compounds now. So I'm going to give another question where concept is same, but instead of molecules for a compound, here we're going to talk about atoms for an element. Okay. Let me just explain to you through a question. Okay. So we've done 3 questions now. Let's do a 4th question. Okay. So I'll give you mass. We need to find out the number of moles. We also need to find out the number of atoms this time. Okay. Find, first one is number of moles. Second one is atoms present in .6 grams of sodium. That's all. Now tell me, is sodium a compound or a metal? It is a simple element, right? It's a metal, right? Simple element. It is not a compound, correct? Okay. Now, how do we find how number of moles? How do you find the number of atoms? So in case of elements, here we are talking about an element, right? So in that case, so the formula that we saw was for compounds. So in case of elements, how do you find the number of moles? In case of compounds, what did we do? Given mass in grams divided by molecular mass to find out the number of moles. In case of elements, right? Then what we should do is number of moles is nothing but given mass in grams divided by not molecular mass but atomic mass. That's the only difference. Of course, once you gain expertise, you won't need a formula, right? You will do it just like that. For example, if this question is asked and you are supposed to find out the number of atoms, sorry, number of moles, what do? You first should know the atomic mass of sodium, 23. So you know 1 mole of sodium is 23 grams. 2 moles of sodium will be 46 grams. Here we have 4.6 grams. So that will be 0.2 mole. That's it. You will answer it like that. Correct? Don't worry. Now we are going to solve it step by step using the formula. Okay. So this is equal to given mass in grams. So how much is the given mass? 4.6 grams. Divided by the atomic mass of sodium. What is the atomic mass of sodium? 23. Correct? So what I will do? What is 4.6? 46 into 10 power minus 1. Yes, because I have shifted the decimal to the right, right? So 46 into 10 power minus 7 minus 1 divided by 23. So 23 and 46, how many times? 2 times. So this is 2 into 10 power minus 1. That can be written as 2 divided by 10, which is nothing but 0.2. Therefore, the answer for the question is 0.2 moles. Clear?
Yes, sir.
Yeah. So it is 0.2 mole. All right. Okay. Now the question doesn't stop here. So this is just a part of the question, right? Which is we found out the number of moles. Now what is the next thing? We need to find out the number of atoms, right? Here also, you see what is the modification in the formula. I'm sure you can guess it. So in case of elements, right? The number of atoms is given by number of moles multiplied by Avogadro number. In case of molecules, what did we do? We multiplied the number of moles by Avogadro number to get the number of molecules in case of compounds. Here, when you multiply the number of moles with Avogadro number, you'll get the number of atoms. Whatever I'm writing here, you can just make a note of it, and just exclusively for formula, you can have a sheet or 2-3 sheets so that you can review it, right? Okay. Once you have enough practice, then all this will become a piece of cake, right? So number of moles is what? 0.2 multiplied by Avogadro number, we know approximately 6 into 10 to the power 23. Please, in your exams, please do not do approximation. Once again, I'm saying, please do it with calculator. 6.023 completely, you're right. Okay. 0.2 into 6, 2 into 6 is 12. 0.2 into 6 will be 1.2 atoms. So the number of atoms of sodium in 4.6 grams of sodium is going to be 1.2 into 10 to the power 23. All right, that's all. Any doubts you have, you can always ask me. If not, we'll proceed to the next type. I will do the reverse also for you. Let's do 5th question. Because this is very important, because if you don't know how to find the number of moles, then molarity or molality, there is no meaning, right? You should be able to do molarity or molality very comfortably. You will be able to do that only if you are comfortable with number of moles. All right. That's why we are spending a little more time. Okay, fine. The reverse I am going to tell for atoms, right? Find the mass of (24) approximately 24 into 10 power 23 atoms. Okay. Find the mass of approximately 24 in 10 power 23 atoms of chlorine. Okay, I'm not given chlorine gas, because if I say, listen to this carefully, if I say chlorine gas, it will be Cl2. Because simply I have told chlorine, it may represent chlorine atom. All right. So let's do it now. First thing is, you are given the number of atoms for an element. For an element, number of moles is given by given number of atoms divided by the Avogadro number for a given element. The number of moles is given by given number of atoms divided by the number of, I'm sorry, Avogadro number, right? So here, how many atoms are there? So here we have 24 into 10 to the power 23. And what is Avogadro number approximately? 6 into 10 to the power 23. I'm just doing approximation so that we save time, okay, right now, not in your exams, okay? So 4. So how many moles of chlorine atoms are there? 4 moles. So the first part of the question is answered, okay? Now we just have to find out the mass. So how do you find the mass of chlorine, right? Not gas, chlorine, but as an atom, right? As an element. Again, for an element, if you want to find out the mass in grams, okay? Given mass of the element in grams, then what is it going to be? It's going to be nothing but the number of moles multiplied by, in compounds we have seen, now mass is nothing but number of moles multiplied by molecular mass. Here in case of an element, it is number of moles multiplied by atomic mass. Right. So this is going to be number of moles. What is the number of moles? 4. What is the atomic mass of chlorine? That's 35.5. 35.5 into 2 is 71. 71 into 2 is 142. Therefore, the answer is 142 grams, right? But in a competitive exams, we will just not do so much, these steps. We'll just do everything mentally, right? For example, we know that 6 into 10 power 23 atoms is 1 mole. So 24 into 10 power 23 will be 4 times of that, 4 moles. 1 mole of chlorine atom is 35.5 grams. 4 moles will be just 35.5 into 4. Directly we'll come to that last step. Clear? Yes. Suppose if the question had been gas, chlorine gas, then it is a molecule. So you should use molecular mass. 71 gram will be the molecular mass. Is that clear? Okay. Anyways. Any questions at this point?
No, sir.
No, right. Okay. Let's proceed further. So next thing that we wanted to talk about was mole fraction, molarity and molality. But before that, one last concept in this mole concept itself, which is volume, right? Generally, if any question is there which has volume, then you can use mass and density, right? Mass by volume is density. So if mass is given, volume is asked, or volume is given, mass is asked, you can use that formula and get it. But specifically at STP, right? At standard temperature and pressure or normal temperature and pressure, right? Which means 1 atmosphere and 0 degrees Celsius, right? In general, right? Of course, for competitive exams, Jayachandra sir had given a different number, right? So it is not 22.4 liters, right? But as far as your text is concerned, as far as your board exams are concerned, you can restrict to this, and this should be good enough for you. But for competitive exams, you have to learn that aspect also, right? We will cover that separately. Right now, I'm just giving some basics for you. So at STP or NTP, all gases, all ideal gases, you will understand about ideal gases. But right now, you can say all gases. All gases. So presently, you take it as all gases, okay? All gases at STP or NTP, standard temperature and pressure or normal temperature and pressure, occupy equal volumes. Okay, if you take equal number of moles, then it will occupy equal volumes. Okay, let me put it here. One mole of all gases, or I can say 1 mole of any gas occupy exactly the same volume. It doesn't matter what the gas is, right? In our class, if you remember, we had done the proof for it. Of course, it's not necessary for you to know the proof, but it's good to know. We are not going to spend time on that right now here, okay? But you can always remember this. At STP or NTP, 1 mole of any gas will occupy 22.4 liters or 22,400 cc or ml. Fine. Okay, now based on this, we can have questions, right? We can have volume to number of moles to molecules to mass. All this is possible, right? So let me give you a question. Okay, let's do a question now, 6th question. Okay. Find the mass in grams. Find the mass of 44.8 liters of carbon dioxide gas at STP. Also find the number of molecules of carbon dioxide. Okay. So very simple thing we are going to use here. So first is we need to find out the mass, right? Whether we want to find out the mass in grams or we want to find out the number of molecules. What is appropriate is if we can find out the number of moles, that's the best thing. Then from there we know what to do, right? So let me give you the formula for number of moles. So at STP, for a gas, number of moles is equal to given volume in liters divided by 22.4. Suppose if it is given in ml, then you can convert it into liters and then substitute in the same formula. Or you should change the denominator. You should change the denominator 22,400 cc or ml. Okay, don't worry about this. So you can take this down as given volume in liters divided by 22.4. So now in this question, if you see, how many liters are there? 44.8 liters are there of carbon dioxide. So I need to find out the number of moles. So first you should write given volume in liters. So what is the given volume? 44.8 in liters divided by 22.4. How much do you think is the ratio? 2. So the number of moles is 2. Once you know number of moles, you know how to find out the mass, you know how to find out the number of molecules, right? So how do you do that? I'm not going to write the formula once again here, but we'll directly substitute, right? So mass in grams is simply given by the number of moles multiplied by the molecular mass. I told you that, right? So what is the number of moles here? 2. And what is the molecular mass of carbon dioxide? Carbon dioxide formula you should know, CO2. So what is the molecular mass? Carbon 12, oxygen 16, 16 into 2. 16 into 2 is 32, 32 plus 12 is 44. Over a period of time, you will remember these molecular masses, right? Because you would have done so many sums. So the answer is 88 grams, that's all. So the number of molecules is the next thing that we need to find out. So how do you find out the number of molecules? This is a compound. So number of molecules is nothing but number of moles multiplied by the Avogadro number. That's all. So how many moles are there here? 2 moles. Avogadro number is approximately 6 into 10 to the power 23. So your answer will be approximately 12 into 10 to the power 23 molecules. I hope it's clear to you. And you can also do the reverse. I guess you can do that on your own. Maybe I'll just give one a small question on that, and then we'll proceed to mole fraction, molarity, and molality. Okay, so let's do the next question, where I give you the mass and you should find out how many liters it occupies. Okay. Okay. Find the volume occupied by 34 grams of ammonia gas at STP. Okay. So always I said, if you keep your answer in number of moles, then it's very easy to find out, the volume or mass, everything. So first step is to find out the number of moles. Is nothing but what? Given mass in grams. Divided by the molecular mass. So here, what is the given mass here? 34. What is the molecular mass? You should know the formula for ammonia. What is ammonia? NH3. So what will be the molecular formula? Nitrogen, the atomic mass is 14. Plus hydrogen, 1. How many atoms are there? 3. So 17 is the molecular mass of ammonia. So it will be 34 divided by 17. Therefore, the number of moles is 2. So once you know the number of moles, I think you can find the volume. So volume occupied by any gas at STP is given by the number of moles multiplied by 22.4, and this volume will be in liters. That's all. So here, how many moles are there? 2 moles. And 1 mole occupies 22.4 liters. So 2 moles will occupy 44.8 liters. That's all. This also, you can take it down as a formula. Okay. I hope it is the basics are clear to you. This pretty much covers maximum stuff that may be needed for you to find out the number of moles or number of molecules or molar volume. We call this volume as molar volume. Volume occupied by any gas at STP is called, your 22.4 liters is your molar volume, which means 1 mole occupies 22.4 liters, right? Okay. Now, next we are going to see is mole fraction, right? This is very important in, usually we want to know in solutions, if you see, right? We will have a solute and we have a solvent. Now, how many moles of the solute are there? How many moles of the solvent should be there so that I get a particular concentration, right? All that is very important. Okay, so we will see what is mole fraction. Mole fraction. Let me talk in terms of solution. Okay. What is a solution? It's a mixture, homogeneous mixture of solute and solvent. Can you give me an example for a solution?
Salt plus water.
Yeah, you just add salt to water. They mix so well, right? You get a homogeneous mixture, right? Similar is the case when you put sugar in water and add them, right? I mean, mix them, right? Okay. So now, suppose the question will be, now, what is the mole fraction of the solute? What is the mole fraction of your sodium chloride, correct? All that may be asked. So let me again give this concept with a question, okay? So we have seen 7 questions. Well, let's do an 8th question now. Find the mole fraction of 58.5 grams of find the mole fraction of sodium chloride. Let me do one thing. Find the mole fraction of sodium chloride when 58.5 grams of sodium chloride is mixed with 180 grams of water. Suppose this is the question. Find the mole fraction of sodium chloride when 58 grams of sodium chloride is mixed with 180 grams of water. Okay. So what are the steps to be followed in finding mole fraction? First thing is you should know the number of moles of both the components, the solute as well as the solvent. You should know the number of moles, right? So let's find out step by step here. So we are going to find out the number of moles of sodium chloride. Now you are experts in finding out the number of moles, right? What is the formula? Given mass by molecular mass, correct? So what is the given mass? 58.5 grams, right? So given mass is 58.5 divided by molecular mass. What is the molecular mass of sodium chloride? Sodium chloride is NaCl. For finding out the molecular mass, you need atomic masses. What is the atomic mass of sodium? 23. Yes. What is the atomic mass of chlorine? 35.5. Therefore, you will get 58.5 as the molecular mass of sodium chloride. So given mass is also 58.5 grams. Your molecular mass is also 58.5. Therefore, you get the number of moles of sodium chloride as 1. So we will call it as N1. Okay, number of moles of sodium chloride. Okay. Now next we should also find out what is the number of moles of water. The solvent also we should see. What is going to be the number of moles of water? Again, given mass divided by molecular mass. What is the given mass of water? 180 grams. So the number of moles of water is going to be 180 grams divided by, what is the molecular mass of water?
18.
18, yes. Because it has 2 hydrogen atoms, atomic mass is 1, plus 1 oxygen atom, which is 16 atomic mass. So you get 18. Therefore, the molecular mass of your water is going to be 18. 180 divided by 18, what is it? 10. Therefore, the number of moles of the solvent is 10. You can write solvent as N1 and solute as N2, whatever is so convenient for you. Usual convention is like that, okay? Solvent is taken as N1, solute is taken as N. Doesn't matter. It does not matter actually. Okay, fine. So number of moles of water is 10. Number of moles of sodium chloride is 1. So what is the mole fraction of sodium chloride if somebody asks, right? mole fraction of the solute. So mole fraction of sodium chloride so let me call it as X2, okay, is nothing but number of moles of sodium chloride divided by the total number of moles of sodium chloride and water. So what is the number of moles of sodium chloride? 1. What is the number of moles of water? 10. Number of moles of sodium chloride is 1. Therefore, it becomes 10 plus 1. So the mole fraction of sodium chloride becomes 1 divided by 11. The formula that you can remember is mole fraction is nothing but the number of moles of that substance divided by the total number of moles in the mixture. Of course, that question is not asked, but I can ask you, find out the number of moles, mole fraction, find out the mole fraction of water also. Suppose you are asked that question. Okay, suppose you are asked to find out the mole fraction of water.
Chi1 plus Chi2 is equal to 1.
Yes, we are going to prove that also. At the same time, we will do it. We can also do it using that idea. Okay. But anyways, right now I'll do it using. Very good. Who answered that?
Me, sir.
Rahil. Very good. Very good. So mole fraction of water, we want to find out, let us say, let's call it as X1. That will be nothing but number of moles of the solvent N1 divided by N1 plus N2. So what is N1? Number of moles of water in this case is 10. What is the number of moles of water? 10 plus number of moles of sodium chloride is 1. 10 divided by 11. Always you can see that X1 plus X2 will be 1. Is it not? 1 by 11 plus 10 by 11. What is it? 11 by 11, 1. Simple mathematics, right? N2 by N1 plus N2 plus N1 by N1 plus N2. Numerator will be N1 plus N2. Denominator also will be N1 plus N2. So it will become 1. So always mole fraction of the solute plus mole fraction of the solvent will always be equal to 1. X1 plus X2 will be equal to 1. This is also another thing that you can learn. Fine. Well, this idea, I hope it gave some knowledge on mole fraction, right? So now we have two more things to cover, molarity and molality. We may require about 5 to 10 minutes to cover this topic. If it is all right for everybody, we can proceed. If some of you are not able to attend, then you may, you may log off. It's a pleasure having you. I will once just read the names and then we will go ahead. Okay. So I appreciate Avinash, Jeril, Kagan, Meda, Rahil, Shamida for being part of this call so far. And if you are able to stay for another 10 minutes, then we will be able to do molarity and molality also. But in case if it's late for you, then you can log off. And I will plan to send the recording of this session by WhatsApp group, but it may take some time. Okay. But anyways, if I'll recommend that you can stay back if you can. All right. So shall we proceed with the next two things?
Yes, sir.
Okay. So let's do the next two things. That's molarity and molality. Okay. This is extremely important concept for conducting your lab experiments. All right. Because all the titrations and everything that you will be doing in the lab are based on this concept. If somebody does not know what is molarity and molality, he or she can never be inside the chemistry lab doing it successfully. Okay. So unless somebody copies, okay. That also you're not sure, right? Whether your friend is doing it right. Okay. So molarity, let me talk about molarity, right? What is molarity? Molarity is a way of expressing the concentration of usually solution. Okay, where solute is mixed with a solvent to create the solution. Okay, Fine. Let's discuss molarity now. Again, we will I'll give you the formula and then we'll go to the question. So molarity is given by the number of moles of the solute divided by the volume of the solution, entire solution in liters. Okay, this can be taken as the formula. So again, it's important to find out what is the number of moles, right? Okay, so let me give you another example here. We'll do two questions. I hope a mole fraction is clear to you. Now we are going to do molarity, right? Let's do a problem. Understand this concept using a problem here. Find out the molarity of 80 grams of sodium hydroxide dissolved in 250 ml of the solution which means sodium hydroxide and water. Okay. So first I would recommend you to find out the number of moles. Now I think you are masters in finding out the number of moles. What is number of moles? Given mass divided by molecular mass. What is the given mass? 80 grams. So given mass must be in grams. Okay. If it is not, you should convert it into grams. So given mass is 80. I'm not writing the formula right now because we already know the formula for number of moles and we have discussed it quite a few times. Divided by molecular mass of sodium hydroxide. So what is the formula for sodium hydroxide? NaOH. So atomic mass is 23 plus 16 plus 1. So the molecular mass becomes 40. So given mass divided by molecular mass 40. So the number of moles is 2. Okay. Now, what is the volume of the solution? In liters, right? So here you have 250 ml. Let me call this as N, okay? Number of moles, I'll call it as N. And the volume of the solution, I'll call it as V. So volume of the solution is 250 ml, which I can write it as, in liters we must write, so it is divided by 1000. Just like 250 grams is what? 250 divided by 1000 kilogram, right? Like that 250 ml is what? 1,000th of a liter. So it is 250 divided by 1000 of liter, okay? Now that's all. Once you found these two, you just have to plug it into the formula, right? So we already seen the formula for molarity. Molarity is number of moles of the solute divided by volume of the solution in liters. So now this, if you want, you can simplify it further. 250 by 1000 is what? 1 divided by 4, correct? So it is 1 by 4 liters. Therefore, molarity M is equal to number of moles N divided by the volume of the solution in liters. So number of moles we have seen, it is what? 2. And what is the volume of the solution in liters? 1 by 4. So this 4 comes to the top. Therefore, it is 8 molar solution. If the molarity of the solution is 8 molar, that's the answer. Okay. Such questions are possible in molarity. In subsequent classes, we can see variations of more, questions that can be asked. They'll give you molarity, you have to find out reverse. For example, if I say the volume of the solution is 1 liter, find the mass of sodium hydroxide that is dissolved in 1 liter of the solution. If the molarity is 4 molar, then you must be able to say 4 molar means what? 4 multiplied by 40 grams, in this case of sodium hydroxide. 160 grams is dissolved in 1 liter. Such concepts we can see later. Okay. So right now we will just do one more concept, which is molality, which is also very important. In fact, in second year, you will be learning about a chapter called solutions, where molarity, all that is very important. Molality. Okay. What is molality? Molality, the definition, there's a slight change, okay, compared to molarity. In molarity, the previous definition, what we saw, it is nothing but the number of moles of the solute present in volume of the solution in liters, right? Present in 1 liter, okay. Volume of the solution. Here you see the definition. Numerator is still the same. It is the number of moles of the solute divided by not volume but mass, and not solution, solvent. So mass of the solvent, not in grams but in kilograms. Okay, this gives you molality. Usually we define 1 molal solution, 1 molal solution when 1 mole of a solute is present in 1 kg of the solvent. Okay. Now let me give a problem and we will understand molality based on that. If you want, you can note down the formula. All these formula must be on a separate sheet so that you are very clear, especially before the exam, you can revise it very well, right? Okay, let's do this question and we'll conclude with that. Okay, I should complete it within another 5 minutes, students. Okay. Find the molality of the solution containing 19.6 grams of sulfuric acid in 200, I'm sorry, mixed with 200 grams of water. See, in case of water, they can give you 200 grams or 200 ml. Okay. Density of water is 1 gram per cc. Therefore, 200 gram or 200 ml I give, no difference. Okay. You must be able to understand that. Fine. So find the molality of a solution containing 19.6 grams of sulfuric acid when it is mixed with 200 gram of water. Okay. So let's find out the molality. As I told you, molality is nothing but the number of moles. So as usual, we have to find out the number of moles. Once we find out the number of moles, then we should divide it by the mass of solvent in kg. Okay, this is what we need to find out. Okay, first thing is number of moles, right? So how do you find out number of moles? Given mass divided by molecular mass. What is the given mass of solute? 19.6 divided by molecular mass. What is sulfuric acid's formula? H2SO4. Once you know the formula, you can find out the molecular mass. Already we have calculated, right? 2 into 1 plus 32 plus 4 into 16, you will get 98. So we divide by 98. So here 190.6, I can write it as 196 into 10 to the power minus 1 divided by 98. So this gets cancelled. You get 2. This I can write it as 2 by 10, or you can write it as 1 by 5. Number of moles is 1 by 5 or 0.2. So number of moles we got, what is it? 1 divided by 5. And mass of solvent in kilogram. How much mass of solvent have I got? Let's see. Let's look at the mass of solvent. What is the solvent? Water. What is the mass of solvent here? 200 gram we have given. But we need it in kilograms. So what you should do? 200 divided by 1000 kg. So what is the mass of the solvent? 1 by 5 kg. So what we got in the denominator, that is also 1 by 5. So the molality of the solution is 1 molal. Usually molality we represent with small m. Molarity we represent with capital M. Yes, I hope you understood today's session. Yes, students?
Yes, sir.
Very good. Okay, just go over it once more, and whatever is needed, you prepare for your test also. At the same time, this is for long term, right? Long term also, this is very useful. So just don't by heart it. Please spend a little time in analyzing it. We will do a lot of questions on them in our sessions. Okay.
Yes, sir.
Fine, students. So it was a pleasure being with all of you. All the best and do well in your tests. And let's have our sessions from Thursday onwards, Thursday evening onwards. Okay.
Bye. Thank you, sir.
Bye. All the best. Have a great day.
Thank you.
I will send the recording
Thank you.
as soon as it is ready. Okay. Yeah. Bye-bye. Bye. Okay, again, your doubts are all cleared.
Yes, sir.
Good, good, good. Okay. All the best. Prepare now.
Yes, sir. Thank you, sir. Bye, sir.
Yes, Maida. Hope it was all clear to you. Shamita, I hope you learned.
Yes, sir.
Very good, Shamita. All the best. How did you do your other tests, Shamita?
Yes, sir. Good, sir.
Good. All the best. So we'll meet you on Thursday.
Bye and thank you, sir.
Bye. Good night. Bye.